So my name is Professor Kristian Leisegang. I'm with the School of Natural Medicine at the University of the Western Cape, based out of Cape Town in South Africa. Currently, I head up the School of Natural Medicine, and I teach clinical science-related modules, particularly around pathology, clinical diagnostics, those types of things. So basically how to diagnose patients and understand pathology and mechanisms of disease. That's been my teaching focus since around 2008. I've been with the university about 15 years. From a research capacity, I started my PhD completed my PhD in 2014 with the Department of Medical Bioscience. So I've got a sort of medical science background in my research orientation and outlook. And my focus then was predominantly on metabolic syndrome, obesity, and the impact that has on male reproductive function, including testosterone, progesterone, and fertility capacity. Post PhD, that's been generally my focus, looking at male reproduction predominantly, and a special focus in and around testosterone and male hypogonadism. What the mechanisms are by the down-regulation of testosterone in men, what the implications are, how that relates to inflammation and oxidative stress, and as well as trying to identify novel, natural treatment options that can be used in this context. So I'm bringing together multiple different disciplines, including male reproduction, endocrinology, immunology, etc. So that's generally what I've been doing and what I do at the moment, and I continue my research in that area, as well as supervising students and so on. Yeah.
So what sort of drew you to like the natural kind of novel treatments?
So my background is in natural medicine. I trained in Durban at the Durban University of Technology as a homeopath, and I'm a registered homeopath as well in clinical practice, although these days I don't do too much clinical practice with my university responsibilities. So I've got the natural medicine background of applied homeopathy and related scopes of practice where relevant in patient management. And as well as being part of the School of Natural Medicine at the University of the Western Cape. So effectively with that background, my research outlook has a component of natural medicine to it. So that's sort of one hand. On the other hand, I think particularly herbal medicines and related products can work in regulating the body in chronic disease as well as health and wellness on multiple different levels, where medication usually aims at a specific mechanism of action to regulate it or control it, to turn it off, turn it on, and that has rippling effects and adverse effects. A lot of good natural medicines, we tend to find we can achieve a level of efficacy for what we're aiming for, but as well as have been beneficial effects on other parts of the body. So bringing together this idea of holistic disease. And I think it's very effective, particularly in chronic disease. So I've also got some experience and background in obesity, metabolic syndrome, and those types of conditions, and the interrelationship of hypogonadism. And in males, and I particularly see the natural medicine as a benefit in fertility improvement as well as hypogonadism, which is very much linked to chronic disease, that poor outcomes, basically.
Yeah. So what from your research would you say is like the main contributing factors to hypogonadism?
All right, so hypogonadism, maybe we should just start with a bit of a definition. Is in males anyway, you get a female variety. In males, hypogonadism is defined as a reduction in testosterone. So, and when testosterone levels are too low, that produces a lot or number of different clinical effects on the body. Most notably, reduction in sexual function, libido, erectile function, as well as fertility capacity. But we see a lot of other clinical features, including increased weights, loss of lean body mass, loss of secondary sexual characteristics, depression and other psychological impacts, fatigue and tiredness, reduction in quality of life. And this is also related with things like hypertension, high cholesterol, diabetes, high blood sugar, those types of things. So hypogonadism is a very important clinical condition that needs to be looked at and needs to be identified, and is currently not something that is on the radar too much. But it affects up to 12% of middle-aged and elderly males and is becoming a significant health burden globally, really. Causes of hypogonadism, well, they vary. We get two types, broadly speaking, what we call primary and secondary. Primary is around testicular failure, and there can be a number of causes there, things like inflammation, chronic inflammation, previous infections like mumps is a famous one, and some genetic diseases like Klinefelter's, but as well as cryptorchidism, which is a retraction of the testes at birth. So these are some causes we can identify clinically, and it's important to be investigated for them, but they're not overly common. Secondary hypogonadism is not when the testes fail to produce testosterone, but they don't get the signal or the instruction basically from the brain. So that's often associated with pituitary conditions like pituitary adenomas, high prolactin in the blood, things like that. And also important to be identified. So these are some important clinical conditions that if there is low testosterone, they need to be looked at and excluded. But they're not overly common in more contemporary times. We see a lot of lifestyle-related hypogonadism. So, well, before we get to lifestyle, an important cause is aging. As males age, testosterone starts to decline with time. Some males that happens faster than others, and we get a range of conditions there's no real name to them, age-related or androgen decline in aging men or late onset hypogonadism. There's a lot of mixed terminology out there. So aging is an important cause, but poor lifestyle, poor nutrition, obesity, the more abdominal weight the male's going to gain, the testosterone is going to go down proportionately. So we can predict that. If I've got an overweight or an obese male in my practice, I can almost guarantee you 9 out of 10 times they're going to have hypogonadism. So those are important causes. Alcohol use, recreational drugs such as cannabis particularly is known to reduce testosterone. Sedentary lifestyle, and those types of things are our main causes that we're dealing with in our modern age.
So, in terms of prevention, the most important basic thing would just be a lifestyle, like proper nutrition, exercise, and avoiding all those sort of stuff that you said would lower it.
Yeah, so if we're going to get to, from a clinical perspective, if we identify a male with hypogonadism, we test them for blood testosterone. That's how we would diagnose it. We would need to then look at the underlying cause. Can we exclude known causes, such as some of them that I've highlighted? We can pick them up in clinical practice, do some tests. They're not difficult to exclude. And then we look at these more broad risk factors. Are they overweight? Do they have hypertension? Do they possibly have diabetes? So those become basically, or can become, a target of treatments. We want to reduce weight, improve nutrition, improve diabetic control. And of course, testosterone gets used in this case clinically quite often. So testosterone replacement therapy, where when males are low in testosterone, they get provided testosterone as a hormone replacement, which improves testosterone, and it improving testosterone improves many of these risk factors, reduce blood pressure, improve cholesterol regulation, improve blood sugar control, improve weight control. The problem is long-term benefits versus risks of testosterone replacement is not clear. There is evidence published where a lot of physicians are not, or doctors are not, that they don't want to overly prescribe testosterone. And of course, there's limitation in access in many parts of the world and many people that don't have the testosterone replacement therapy. So, and it also has side effects on fertility. It will reduce fertility adversely, having high levels of testosterone, as well as contraindicated in males with prostate disease. So it's a solution, a widespread solution, testosterone replacement therapy. But I think what emerges out of that is improving testosterone in these conditions does help contribute to reducing risk of heart disease and strokes and diabetes and those types of conditions. So it's very important you have a look at male health, physiology, look at their testosterone levels, look at their lifestyle, and aim to try and improve that. And if we can find or alternative ways to improve testosterone, such as natural products, in males in this context, I think that would go a long way in improving the burden of low testosterone in the population.
Yeah. And you know, with TRT, obviously it's shutting down your natural testosterone production. So it's basically, not only is there all the sort of like unknown with it, if you get on it, it's kind of a lifelong commitment.
Yes.
And if you, sorry, go on.
No, sorry, you will shut down your natural testosterone, yes.
Yeah, and so if you get on it at a young age, you're basically saying, well, I'm okay with injecting myself, you know, every couple of days or once a week or whatever for the rest of my life. And if I don't, I'm gonna have like zero testosterone.
Yeah. Or you've got to come very, tailored off very slowly. Yes. Yeah. And testosterone is a steroid hormone, and I should have also mentioned, because it's a common treatment for other conditions, is corticosteroid use or steroid use, which is also common medical treatments. That also shuts down and lowers your testosterone and puts males into hypogonadism.
So antioxidants, oxidative stress. What sort of role does oxidative stress play in hypogonadism?
Those are still areas of inquiry and somewhere that I'm interested in and that I've looked at. So little is known the mechanisms by which testosterone is shut down. So there's a specific type of cell in our testes called Leydig cells. The cells responsible for testosterone production, predominantly in males. And in cases of low testosterone, the mechanisms by which testosterone production is reduced by these cells isn't well understood. There's an area I've looked at partially and continue to look at a little bit at the moment. But one of the mechanisms we've seen in the context of obesity appears to be oxidative stress. So what happens is, with an unhealthy lifestyle, too much toxin, too much alcohol, those types of things, or obesity, we have an increase in inflammation, which tends to do more damage than good. And we also have associated with that an increase in oxidative stress. And what appears to happen in this context in these cells is stimulates oxidative stress within the cells, which downregulates the genes responsible for making testosterone. So oxidative stress, particularly in poor lifestyle, obesity, exposure to toxins and those types of things, has the capacity to induce oxidative stress in these cells, and that oxidative stress causes damage to the mechanisms by which we produce testosterone. So it seems to play a very important role, and that's why I'm particularly interested in plants that have antioxidant impact and what they do in this context and in these cells. So looking at these cells and exposing them to inflammatory cytokines or other methods that create dysfunction in these cells, and co-exposing them to plant extracts to see, can we reduce the impact of this oxidative stress and restore testosterone production in these cells, at least in a cellular level? And if so, then maybe we can amplify that into animals and humans.
Yeah, that would be a very interesting study, perhaps a sort of regimen of maybe an antioxidant-rich diet or supplement regimen, and kind of see what sort of role it would have.
Yeah, so in this context of obesity, that induces inflammation, oxidative stress, which in turn decreases testosterone. Testosterone also regulates immune function and oxidative stress. So as we start seeing lower testosterone, we conversely see more fats, more inflammation, more oxidative stress, which then causes more damage to all cells, including these cells making testosterone, lower levels, and then you just get into this cycle. So by targeting inflammation, targeting oxidative stress, and targeting testosterone production in males, you can look to balance a lot of these systems out in this context of chronic disease.
Interesting. In your ED systematic review, it talks about the Mediterranean diet, because the Mediterranean diet's notoriously rich in antioxidants as well. So is it sort of a fair assessment that if you were to increase your diet with antioxidant-rich foods, you could see a benefit with ED?
Yes, definitely. Out of that paper, there emerged well, relatively speaking, there's little clinical research in many of these areas.
Yeah.
But yeah, improved diet firstly, and specifically the Mediterranean diet, which is rich in antioxidants and healthy fats and oils, improved weight and improved testosterone, improved inflammation. It's not clear how it does that. Does the oxidative stress directly help testosterone production, or the antioxidants, that you're eating, and the nutrition that you're eating? Does that reduce inflammation, oxidative stress, which allows testosterone? But does some of it act directly on the cells to produce testosterone, which is off inflammation? So how it works exactly, we don't know, but definitely through immune regulating and reducing oxidative stress.
Interesting. What role does cholesterol have in testosterone production? Because I saw the graph on one of those papers, and obviously cholesterol generally has a pretty negative connotation, but from the looks of it, it's actually used to produce testosterone.
So yes, cholesterol gets a very bad rap, unfortunately. To answer the question directly, cholesterol is absolutely essential for testosterone.
Wow.
Testosterone is made from cholesterol through a process. To take a step back, we've got a group of hormones that we refer to as steroid hormones. Of those is cortisol, which is our most famous steroid hormone. We've got other ones such as aldosterone. We'll leave that off, that acts on the kidneys. But part of these steroids are a class of them called sex hormones, which is testosterone and your other androgens, such as DHEA and so on, estrogen and your other estrogen-like compounds, and progesterone and its related friends, pregnenolone, etc. These are all steroid hormones, and all of them are made from cholesterol. So essentially, to make any one of these and their related families, there's 30, 40, 50 of them, you start with cholesterol. And cholesterol then gets turned into or converted into a hormone called pregnenolone, which is part of the progesterones. That becomes progesterone, and from there we can produce, under different enzymes, all of these different types of steroid hormones, including testosterone. So if we don't have enough cholesterol, you're not going to make enough steroid hormones, including testosterone, definitely. Cholesterol gets a bit of a bad rap because cholesterol is absolutely essential for body function. We need it for cell membrane integrity, for cell membrane fluidity, so proper cell health on all of our cells throughout the body. Our brain is rich in cholesterol. It's a very important fat alongside different types of polyunsaturated fatty acids. So our brain is essentially made up of a lot of cholesterol. It also contributes separately to vitamin D production. We make vitamin D in our skin with exposure to sunlight from cholesterol, essentially, or other metabolites of cholesterol. But with the idea of high cholesterol causing heart disease, cholesterol is generally frowned upon. And this is a little bit more of a complicated story because cholesterol is just one molecule. There's only one molecule called cholesterol, and it's very important for our health. The way we transport cholesterol around the body is a different story. We make proteins which help take cholesterol around the body appropriately. Two of them are famous, LDL and HDL. LDL is the so-called bad cholesterol, and HDL is the good cholesterol. Now, there aren't different types of cholesterol. There's only one type of cholesterol. What we refer to as good or bad are the carriers. And the bad takes cholesterol from the liver to the body where we use it for good things. And the good, HDL, clears that excess cholesterol back to the liver. And if we get too little of the good cholesterol and or too much of the high cholesterol carrier proteins, we get an imbalance. And we get too much of this bad cholesterol, LDL, it's not really bad, in the body, which then undergoes oxidative stress, and it becomes oxidized LDL, which is toxic to the body, and that creates localized inflammation, and that starts these atheromas or plaques in the blood vessels for heart disease and strokes and things like that. So it's really oxidative stress, too much, and an imbalance in how we transporting cholesterol. Yeah, and that comes down to lifestyle again at the end of the day.
So if you have let's say a good lifestyle and you're not exposing your body to tons of oxidative stress, it's perhaps that you could use more of the cholesterol for perhaps testosterone production, brain function, whatever, and then it won't get oxidized and it won't have all these negative effects that make cholesterol bad,
Yeah, exactly. That how your body regulates the metabolism and transport of cholesterol will be optimal, and you won't accumulate this as quickly as possible. Yeah.
Interesting. Can you explain how free and total testosterone work with SHBG?
All right. So, so testosterone is made in males predominantly in the testes, and it's made from cholesterol. And as many might know, cholesterol is a fat. And fatty things, let's call them that, fatty molecules or fat-soluble molecules need to be transported in the blood, like cholesterol. That's what we spoke about. So just like if you put a bit of fats or oil in water, you don't see the oil dissolve.
Yeah.
You don't want that with sort of fat-soluble products in our blood. So we sort of dissolve fat-soluble things by binding them to a protein. Okay, that LDL and HDL, those are proteins that bind fats to solubilize them in blood, essentially, and transport them. For testosterone and other sex hormones, we have what's called SHBG, or sex hormone binding globulin. So it's a big name, but it's basically just the protein that binds sex hormones, testosterone and estrogen, etc., to transport them around the body because they are fats. Okay. However, so this is how we transport these hormones. However, when testosterone is bound to sex hormone binding globulin, or SHBG, it's what, let's say, inactive. We know we use two technical terms, but it's not available for use by the body. And when we measure total testosterone, we're often measuring how much testosterone is bound to SHBG. You can't really tell the difference. So in clinical practice, you might have normal testosterone levels, but that testosterone might be bound, most of it, and it's not available for the body. So you could still have this sort of clinical scenario of low testosterone, even though testosterone levels are normal. Mm. So that's what we call total testosterone. You don't really differentiate how much of it is bound and unavailable to the body for use and how much of it is free. So this now brings the other context. You've got your total testosterone, and then you've got this concept of free testosterone. Okay, there's another one that's related to that called bioavailable testosterone, but it's the same concept. I won't differentiate those two. But essentially, when testosterone gets to its target, it needs to come out of the blood and go into the tissues, and it releases from the protein that's in the blood. And then it crosses cell membranes, it goes into cells, and it attaches to receptors, and it does its job. That's when it's free or bioavailable, that's not attached. And of course, you need the right amount of that of testosterone to be free in order for it to be doing its work. And we can also measure this in clinical practice. So you can measure total testosterone and free testosterone. I always do both. And free testosterone is often calculated by a ratio using the SHBG levels and your total testosterone levels, which is fairly accurate. There are other ways. You can do saliva testing for free testosterone, which is probably better. It's not as readily available, and it's a lot more expensive, unfortunately. But it is a lot more useful, and specifically, that's what we call bioavailable hormone. It's hormone that's not only free, but it's in the tissues doing its job. You can have a scenario where testosterone looks normal if you just do total testosterone, but you do free testosterone, you might find that that's actually low. Maybe because sex hormone binding globulin is high. Sometimes that's high for various reasons as well. And if that's too high, you binding too much of your testosterone and not enough is available for use.
Interesting. So what would be one of the reasons perhaps the body might have too much of your testosterone bound up?
They're often related to liver conditions. liver disease, or even just liver dysfunction, things like non-alcoholic fatty liver, which again we see a lot in obesity and diabetic patients and things like that. So often it relates to the liver making it, as well as exposure to hormones like cortisone, as well as testosterone itself as a hormone replacement.
Interesting. So if you want less testosterone to be bound, you've got to look after your liver.
Yeah.
Cool.
Well, essentially a lot of this relates down to, especially in the context of chronic disease, which is where we're talking mostly, comes down to regulating all of these areas. The liver plays an important role. Fat cells themselves play an important role. In males, the testes play an important role. Females, the ovaries. So you need to get all of these systems aligned, doing their job properly. And that's where natural approaches come in very well, because they tend to have multiple benefits.
Yeah.
But not common mechanisms like inflammation, oxidative stress, glycolysis. They started.
So what drew your attention to Tongkat Ali?
My supervisor for my PhD worked also, he's a male reproductive health expert, Professor Ralph Henkel. He's now in the UK, Imperial College in London. And he did a lot of work, or was also doing work with plant-based compounds, which I've continued to collaborate with him, and we continue to do work together in this area. Looking at Leydig cell function, which makes testosterone, but also looking at sperm function and looking at various different types of natural products which might have benefits in laboratory experiments, almost screening them. So I've been exposed to a lot of that, which is also ideal with my background. He's more of a traditional medical science background, now doing research on plant products and antioxidants. So we built the collaboration going forward from there, and he had worked with Tongkat Ali with colleagues in Malaysia. I wasn't part of some of those projects, but during my PhD time, and that's where I'd first come across Tongkat Ali. And since then, I have been interested in it, and I have not been able to get specific studies done. We've looked at a clinical trial, we've looked at a few other approaches, but funding is always a bit of a difficult part, and other projects at the moment too. So we looked at doing with some other colleagues, Dr. Renato Finelli, who was my co-lead author on the paper, as well as Manesh Kumar and Professor Sika from USA. We decided to look at Tongkat Ali in terms of what do we know of its impact on testosterone in males. So bringing together the clinical studies that have been done in humans that may or may not have hypogonadism, and putting them into, sorry, I just got a little distracted. And trying to put them into a specific paper, or specific place, so we can analyze them as a whole and see what do we know, is there positive impact. This context of systematic reviews and this context this concept of systematic reviews and meta-analysis, they are done as almost the highest level of evidence. So one study doesn't prove anything, and people do study all sorts of medicines across the globe. And what we need to then do is look at all of those as a total. So we have research methods and statistical methods which can then pool all of those papers into one place and analyze them systematically, or we can do statistics on them and basically make them into one big study, increase the number of people, and getting much more certainty on our results. So we looked through the literature and we saw there were a number of clinical studies. So we decided that there wasn't yet a systematic review of meta-analysis. So we took the opportunity to, at this stage, to have a look at those clinical trials and pool the data.
Great. And what would you say was the kind of overall findings of the systematic review of Tongkat Ali?
So our review, what we found, we searched a number of databases, and ultimately we found 9 clinical trials which met our criteria, which is very important. On obviously males, either healthy males or with hypogonadism, and looking at specific outcomes. They had to measure testosterone in the blood. Those are some key concepts. So, with those restrictions in place, we found 9 papers which we could put into a systematic review. And the majority of them, if I'm not mistaken, 7 out of the 9 showed a positive impact on, or reported positive impact on, of Tongkat Ali on testosterone in males. So we can break that down further because there were some differences in them and what they looked at. But the overall impact in both males with normal testosterone as well as males with hypogonadism tend to improve cholesterol. Improve testosterone. Some of the papers, 5 of them, in fact, we could then use based on how they reported their data. We could then take that data and put it into a statistical methodology we call a meta-analysis. So we could pool 4 of them. We weren't able to do this because they didn't report the data in the way we would need it to be done. But 5 of them we could put into the meta-analysis, and basically that's making one big study. And what we found there statistically was that Tongkat Ali improved testosterone in males. So with very good, strong evidence, we broke that down further into specifically males with low testosterone or hypogonadism, and we saw an increase in testosterone, as well as males with normal testosterone. So in those cohorts, we also saw an increase in testosterone. So there are some limitations. There's not too many studies, but it's not too few either. And the sample size in many of them is relatively low. But they do clearly show at this stage, at least if we look at these as pilot studies, preliminary studies, that there is a significant positive impact of Tongkat Ali on testosterone.
Interesting. Yeah. That's basically the conclusion we came to.
Yeah. Yes. No. And yeah. Now I've had a look, and no, it's quite it's almost remarkable. On one hand, if you look at it, like I said, it's few papers, small sample size. But if you look in the context of clinical trial research of herbal medicines, there are very few.
Yeah.
There's a lot more in animals. There's a lot of cell culture work, but that needs to translate into humans. And if you go looking at the literature for almost any other potential herb, which we see benefit of either in folklore at a traditional level or at a cell culture level, and in animals, there's plenty of them which show improved testosterone. Almost none of them have been translated into clinical trials at this stage, let alone for a systematic review or meta-analysis. So in that sense, it's quite remarkable on how many there had been on Tongkat Ali. And I think this comes from a push from Malaysia. It's a Malaysian herb, basically. And the Malaysian government for a good few decades has put it as part of one of its sort of flagship exports to the world. So there has been a lot of funding in Malaysia. A lot of the studies that we had included had been based in Malaysia. So when you get a little bit of backing financially or politically or otherwise into these areas, then you can do the research, do the clinical trials, and start, getting the results. But, I think generally most parts of the world, it's very difficult for that type of funding for clinical trials, which are expensive.
Yeah.
Unfortunately. So I think in that sense, Tongkat Ali is, especially in the context of male reproduction broadly and specifically in testosterone, by far the most researched herb out there. And the research that is available is clearly showing benefits on testosterone levels.
Yeah. In the studies, were you able to work out sort of the mechanism of action? Because it's not clear from online sort of research whether it increases LH production or if it just lowers SHBG.
So this is very unclear. The short answer is no, it's not very clear at all. The mechanisms by which we do know, I'll come to the LH and SHBG now, but what we do know across a number of lines of evidence is Tongkat Ali is immune regulating, it's anti-inflammatory, it reduces oxidative stress, and these are mechanisms associated with low testosterone. But they haven't been looked at directly, particularly in humans, if the Tongkat Ali extracts are able to regulate these and improve, and that's the mechanism by which they improve testosterone. We don't know. So we would be hypothetically drawing those conclusions. It hasn't really been investigated yet. Then we can look at other related hormones. So LH is a hormone produced by the brain, the pituitary specifically. And it regulates testosterone, or helps regulate. So LH stimulates testosterone production. So when we have increased LH, we stimulate testosterone. And one way we can increase testosterone is by increasing LH levels. And so, of course, this might be a way that Tongkat Ali is working, and that has been looked at. In the clinical trials we had, the ones that did measure LH did not seem to show a positive impact. Okay. So there doesn't look like it increased LH in many of the clinical trials, but very few of them, I think only 2 or 3 measured LH. Because the focus was on testosterone, and of course these, each thing we add adds a lot of money to the clinical trials. In animals, however, there are a few animal studies which seem to indicate testosterone is increased by increasing LH. So it seems to be a little bit different there. But at human level, it doesn't seem to be as much evidence, but it hasn't been looked at very much. And we see very much a similar story with sex hormone binding globulin, or SHBG. In animals, it does seem to be changes with it, but in the human studies where they measured it, there seemed to be no specific change. Same with DHEA, which is another related androgen. But very few studies in humans have looked at that, so we just don't know.
Interesting.
At this stage. I would suspect that it has to do a lot more with regulating inflammation and oxidative stress.
Okay. Interesting. From our sort of observations with customers and my own personal use, it seems that the body builds a bit of a tolerance to Tongkat after a couple of months. So what we do is we suggest take it for maybe 2 or 3 months, and then maybe have 3-4 weeks off, and then kind of like cycle it. I was wondering if you had any sort of ideas on that.
Yes, so let's start with the evidence that we can, from the papers that we've looked at. Unfortunately, most of these trials we included were relatively short duration. I think one of them went up to 6 months.
Yeah,
possibly there's a longest one. But they were sort of, you could say, maybe 12 weeks, that sort of period, 8 weeks, 12 weeks. And none of them really have a long-term follow-up. We don't know what happens at the end of the trial. The patients continue taking them? Did they stop? What happens 3 months later? There is a clue in 2 studies, I think. I stand to be slightly corrected. I think one was in endurance in cyclists, and after 3 weeks, it improved testosterone. And it then after stopping it, it reduced off, which isn't quite the cycling, but it mainly was show that the Tongkat Ali was having a benefit effect. And another one showed no clear improvement after 8 weeks. But in terms of looking at months of use, that we don't know. In clinical practice, we do see this. I think the body, if we take a broader look at this, the body is highly adaptive.
Yeah.
And we do start if we're having an increased stimulus of anything, we're going to start adapting to it.
Yes.
So, and in many products, we might find this type of thing happening, particularly around steroids in the body and regulation of fat, etc. So, it's very plausible that does this happen, and it does get reported. And I think the best way to do it, because it gets done with things like Panax Ginseng, is also another herb where it gets adaptive over time. That you have these periods of almost like a washout.
Yeah.
Where exactly they are, how long they should be, we don't know, because no one's tested that. So you're in the realm of, you've just got to see different patients, different settings, and how it works. But if there is a sense of tolerability building up, if that's the right word, or adaptability, then to pull it back a bit for a little while and cycle it like that is the best approach until we know more.
What are your thoughts on kind of the role of genetic makeup on the effectiveness of a supplement or any compound, really? Because it seems that from our experience, what works for someone will just not work for somebody else, or they will respond completely differently to it. Why do you think that is?
Well, that would be multiple reasons. One of them would be genetic makeup, definitely. Which we'll come to. But I think from a natural medicine point of view, in many traditional medicine principles and philosophies, we see the patient as an individual, and we try and individualize parts of the patient, their disease, their constitution, even sometimes their personality, and try and mold specific treatments to that. So, in my practice, I might have 10 patients with, let's say, polycystic. Okay. I don't know if you're able to edit this, but this is what I was worried about.
Nothing. That's absolutely fine. We can cut.
I have some noise now. Yeah, it's very unfortunate. Can you hear that noise?
Vaguely. It's fine.
Let's continue then. I hope you can edit it out. It's also I was distracted. People have come and they're working out in front of my window. And they come every 2 weeks, and I sort of forgot about it. So I just had them appear just now. I thought, they're going to start making a noise.
No.
And then they didn't, but now they're back to make the noise. And it did throw me out a little bit there. Okay, so where we were talking about the sort of genetic makeup. So patients are individual. Patients have individual response for various reasons, and we try and treat similar conditions, sometimes with different medications or different approaches from natural medicine based on these individualizing areas. Conventional medicine is having a bit of a similar revolution at the moment. The term used there is this idea of personalized medicine, where you can look at, are there markers in a disease that can show how responsive patients will be to certain types of treatments. And they certainly are. And genetics is one of those areas that is very closely looked at. So just to bring this down to the genetic level, we're all individual. We all got different sets of genes and variations. And in many of our genes that control many of our bodily functions, we have some minor mutations that can sometimes put us at increased risk for something and sometimes put us at decreased risk for something or have benefits. And a lot of research is going into these different types of mutation, different genes, and what it means from a diagnostic point of view, prognosis, and a risk point of view. But also they're looking at it from a treatment point of view. So we do know from research into pharmaceuticals that patients do respond to different medicines based on genetic makeup. Statins is one area that's been looked at, statins for lowering cholesterol, and they're getting much better at trying to identify who's going to be a good responder, who's going to have a lot of adverse effects and no response. So and what are the alternative options that they might have. So genetic makeup would, I believe, based on this, would definitely have an impact on how we regulate our nutrition, and as an extension of that, any sort of metabolites or compounds we get from plants, so herbal medicine, antioxidants, nutraceuticals, all of those types of things we will respond to slightly differently based on our genetic makeup, all these little mutations and how we regulate things around our body. But in terms of pharmaceuticals, that's really the tip of the iceberg being looked at the moment. In terms of nutrition, supplements, that's not looked at very well now.
Interesting. Do you think Tongkat Ali, what would have to happen for it to be kind of recommended properly in like clinical practices over like something like TRT?
That's a tricky question. We're in the realm of clinically translating. I think if you're going to look at it from that perspective, it's going to need a good evidence base, but it's also going to need a good PR campaign, really. If you look at how a lot of effective drugs are distributed and marketed into practices, into recommendations by practitioners, and so on and so forth, they tend to come from a lot of marketing and branding interaction. For the most part, and as well as seminars and events and presentation of the research and that they have. So I think that's on one hand. On the other hand, is this idea of approvals. So if you look maybe at the US, you've got the FDA, and many practitioners in the conventional sort of stream would want to err on the side of things that have been FDA approved for specific use. There's a bit of an irony here I'll come to. But, if you really wanted to get to that level, in my opinion, it's a complex area. People will have different opinions, I'm sure. But, you need to get the science. If you want to, you need to get the clinical evidence, and you need to go for approval from regulatory bodies in the UK, in the US, in South Africa, that you can then say, they give an approval that this product made in this way is beneficial or approved for treatment in, say, hypogonadism. So, that would make a big difference, but that's, quite far to reach in many senses. But if you've got products approved for use, there would be, and we have seen that in some products. I stand to be corrected, but things like melatonin have got some approval in some countries and regulatory bodies now. Some of the pre-hormones like the HEA as well, so it's very hormonally regulated. You've got sort of this almost this in-between conventional and natural medicine almost area of the bioidentical hormones, which testosterone is part of, estrogen, we have a lot of those creams getting sort of regulated. So that would be the most important way to go. Otherwise through marketing and buying. But unfortunately, we live in a world of regulatory approvals, which would be most important for most practitioners, I would say.
A few months ago, I had a conversation with I'm not sure what she was. I don't think she was a doctor. I think she was a clinician. She had her own clinic. And she'd been recommending Tongkat Ali in a low dose to women with menopausal sort of symptoms. I was wondering if you've got any insights into how women could use it.
Yes, that is true. The Tongkat Ali is used in that scenario and to great effect in many cases. I'm aware of one paper as well that has been done where they investigated the impact of Tongkat Ali on testosterone levels and other hormones in perimenopausal women, as well as effects on sexual function outcomes. And that paper showed, I can't remember the details offhand, but it did show benefits. Reduce the symptoms of perimenopause and menopause, and improve sexual function, improve libido, as well as some of the mental health areas such as anxiety and irritability and those types of symptoms. So there is some clinical evidence supporting that. And I think it's important to note here that, Tongkat Ali doesn't necessarily have to fall in the male domain. It does seem to improve testosterone in females, and females going through menopause. Lower testosterone levels is a big driver, not just the lack of estrogen, but testosterone, they're related hormones. So testosterone levels also drop quite significantly, and which contributes to the symptoms around the perimenopausal state. So testosterone is used clinically to improve some of these, which it does, and like as a hormone replacement therapy. But Tongkat Ali, by improving the production of testosterone in the female body, seems to have a positive impact. But a lot more studies would need to be done.
Yeah.
Maybe need to look again. But there's definitely one, and it was quite a good study.
Yeah.
That supported that.
Interesting. Did your research uncover any side effects of Tongkat Ali?
So the papers we included, not all of them report adverse effects, unfortunately. In the ones that did, which was the majority if I'm not mistaken, there was few to no adverse effects reported. The one area when there was adverse effects reported was mild, and it had to do with GIT upset particularly.
Yeah.
And which does get reported a little bit also sort of in the communities. Or in people who are taking it traditionally. So there might be some tolerability issues in some people, but they look very mild and infrequent for what we can see. And there's certainly no sign of serious adverse effects or people dropping out from clinical trials or things like that.
Yeah, that's pretty much what we get. A small percentage of people have like an upset stomach or something.
Yeah.
But what we suggest is just drop down the dose. Lower the dose for like a week or two, and then they can kind of build up to it.
Yeah. That's a good practice, yes.
Have you seen any other herbal supplements that have like similar promise to Tongkat Ali?
There are a number of them. I'd had a few somewhere. There's a number of herbs that are used, hundreds. Other compounds that are used traditionally for male sexual health. A lot of that is aimed at the sexual component of sexual health, but a lot of it also then at testosterone and hypogonadism. So many are used traditionally. Some I've been involved in looking at recently is Sutherlandia, which is a local herb in South Africa, which may improve or at least protect against inflammation and oxidative stress induced lower testosterone levels. Withania somnifera is another one that gets a lot of attention, and some compounds like resveratrol is also being shown to get a lot of attention. But generally seeing in a lot of these herbs that they are herbs or extracts from plants like resveratrol that have high antioxidant capacity. So again, I think it shows that there's a relationship there. But none have been tested in humans. Very few to none of these have been tested in humans. A few have been tested in animals, but many of those animal studies are in the context of inducing damage chemically or nutritionally. And a few more have been done in cell cultures, so they expose cells to these herbs, but very few that are just the cell itself. Again, it's in the context of damaging the cell, usually with oxidative stress. And the other problem is, of these herbs that have been tested either in cell culture or animals, there's usually only one study on that herb. So 5 or 6 or 7 of these studies, which we have summarized in a paper on hypogonadism treatments, that seem to have potential, but we need to test them in humans. There's one I want to point out, one I have worked on as well, is called Nigella sativa oil, or Nigella sativa. It's the common name is black seed. And black seed, it's commonly used in a lot of North African dishes and Mediterranean sort of dishes. So it's a very popular herb. And out of the seeds, we extracted oil, which has been used a lot in traditional medicine. And we've looked at that in animal studies in our labs, and it is supported by a lot of studies. So it's another herb that has quite a decent amount of research, at least in the animal level, not so much the human level. But it also seems to be effective in improving testosterone levels. So there's a lot of potential ones that in preclinical studies, but very few that have gone into clinical studies. There are some actually more famous ones I should mention, come to think of it. Panax Ginseng. That's one that's got a lot of reputation for improving testosterone. It has been looked at, particularly in the context of erectile dysfunction, in 2 or 3 studies, and no improvement in testosterone. Had a good improvement in erectile function, but doesn't seem to do this by improving testosterone. But none of those patients were hypogonadism, so we don't know really what it would do in that context. Tribulus Terrestris is another famous herb that's often used to improve testosterone and for erectile dysfunction. Again, good evidence for erectile dysfunction, but the studies that also looked at testosterone in humans seem to show no impact on testosterone. So, there's few areas where this has been looked at, often as a marker for something else, testosterone measured. Those herbs that are said to improve testosterone don't really seem to do that. So Tongkat, in terms of clinical evidence in humans, to me, is a bit of a standalone.
Yeah.
If we wanted to go by clinical evidence for improvement of testosterone in humans.
Yeah. Interesting.
If we look at it from that perspective.
Yeah. In the future, we would love to kind of sponsor a clinical trial. What would you say would be like the best trial we could do for Tongkat Ali?
Well, if we wanted to go about a clinical trial, you would need to, the first thing we'd start with is just trying to identify a couple of broad parameters. Who would want to test it in? So, for example, it would obviously be males. Would you want to look at normal healthy males? Would you want to look at males with hypogonadism and those sort of things? So that can help us. We need to identify sort of whom it would be. And I'll come back to that. The intervention is also important, which would be Tongkat Ali, exactly what it would be, but also the duration and the dosage and things like that would need consideration. And then linked to who we want to measure, it's what do you want to measure? So you might want to measure testosterone pre and after, but there might be other areas you want to measure. So for example, you might want to look at testosterone in healthy people who are looking to improve endurance.
Yeah.
The outcomes at all, you can measure testosterone pre and post, but you have other outcomes that are measuring fitness or endurance, or it could be muscle mass or muscle strength.
Yeah.
That could be one area. If you wanted to look at it as so that could be from a healthy male supplement perspective. You could look at from another area as hypogonadism. Males who have hypogonadism for whatever reason, maybe they're linked with obesity, maybe not, or whatever, and does it improve testosterone in these males, and does it improve some of these associated features? The best place to look at is difficult to say, but I think we would definitely want to start showing, or at least add to the literature of improvement in testosterone. I had a study with some collaborators here at the University of the Western Cape, which we couldn't get funded. We wanted to look at the impact of testosterone in obese males and look at outcomes in terms of endurance, in terms of strength, and in terms of reproductive capacity. So we had access to sports science. I will have access, and they, can do the work on taking the males and having a look at strength and endurance. And in our laboratories, we could do the reproductive and testosterone side. And particularly from, where I've been looking at metabolic syndrome and obesity. So in this context, can Tongkat Ali improve muscle mass in obese males, and reduce obesity? So not only do we get the testosterone, but are we getting some of these additional benefits we should be seeing with increased testosterone? Are we seeing the reduced weight? Are we seeing increased muscle mass, increased endurance, increased strength? Is testosterone levels normal? Is inflammation regulating itself? And do we see improvements in sexual functions such as erectile function and sperm function? So, we had, at least across 3 departments, we could bring that together. Unfortunately, like I say, that got suspended. But I think this idea of, it seems to increase testosterone, but in a specific cohort, do we see these added benefits of endurance and strength, maybe in healthy males, and in decreased risk of chronic disease in males with hypogonadism, or in other symptoms associated with that?
Okay. Visit nfsupplements.co.uk to get 3 for 2 on our entire range of natural supplements.